Welcome back. So this week in college algebra, we're going to continue looking at radians and particular things about radian angles. So today we're looking at coterminal and then complementary and supplementary. And then tomorrow we're going to look at how to convert from radians to degrees. I think both today and tomorrow should not be too bad. It's actually probably easier than last week's. And then we'll look at some angle speed things on Thursday that might be a little more challenging. So the first thing, I have the topic up there. I have the essential question. I typed them up so it's easier to read. And then we're going to look at coterminal angles, what that is. So we talked about it a little bit. We looked at radians for the first time, but a coterminal angle, those are angles where the terminal end or side, where the terminal side ends at the same place, basically. So if I come up it over here on the side, again, when we have our coordinate plane, remember angles start here at the x-axis or at 0. So this is the initial side, and then end someplace. So let's say we had a 90-degree angle right here. Okay, so in terms of radians, this would be pi over 2. However, there's another way to also end at that exact same spot. Like we talked about with negative angles, for example. If I went the negative direction, I could go this way. It would end at the exact same spot, but it wouldn't be pi over 2. It would have been negative 3 pi over 2. So those two angles are coterminal because they end at the exact same spot. So that terminal side ends the same place. So that's what makes them coterminal and have the same ending. So we're going to look at some examples here and just try to name coterminal angles. So the directions say find a positive, not very good positive, but positive, and negative coterminal angles. Okay, we're gonna look at we'll look at about 4 of these if I have time to go through it. We'll see at least 2 or 3. So the first one is, let's say we have an angle. We'll do it in radians first. Sorry, degrees. So theta equals 37 degrees. So again, theta is just another way to name angles. Often in trigonometry we use Greek letters. So theta would be 37 degrees, which means I have some angle here. If I'm looking at my unit circle kind of idea, this is my line. Here's my terminal side. This is 37 degrees. That's what theta means. Okay, so what's another way to have that exact same spot? Okay, so let's look at the positive first. I'll kind of put maybe for each problem here we'll do columns. So positive, and then negative, because for each of these we're trying to find each. Okay, so for the positive one, what's another way to end at the exact same spot? Which means I have to start here. I have to go in the positive direction, which is this way. So 37 ends there, but no other number right there. I'd have to go all the way around and then back to 37. So all the way around would be 360. So I know it goes all the way around plus an additional 37. So another angle that stops at the exact same spot would be, 397 degrees. So that would be a positive one that ends at the exact same spot. Okay, so what about a negative one? So I'm looking at negative. We'll pick a different color. We'll go with, let's go with pink, go backwards here. So I can look at here. This is the exact same spot. We're starting here. But now again, negative, we're going the opposite direction. So the whole way around would be 360. If we don't quite make the whole way around, we actually stopped 36 short. So you subtract 37 short. So it would be negative 323 degrees. That'd be the negative side. Okay, or probably think about it like 37, you're subtracting 360. But I like to think of it the whole way around, minus that little bit, so it'd be negative 323 degrees. Okay, so let's say we did this. We'll just do 2 of these examples, because I think you can handle it with just 2. Let's say we had a radians one. So let's say we had radians. Let's pick kind of a hard one. Let's go with 13. That's not 13. That's 11. 13 pi over 6. Okay, so the first thing I have to do is figure out where that is. So where is 13 pi over 6? Okay, so if I'm thinking about 13 pi over 6, again, I'm going to take my coordinate plane here. I'm starting. I'll use blue here to kind of see where I'm starting. I'm starting here. Okay, again, with radians, this would be pi over 2, pi, 3 pi over 2, This is 0, and then 2 pi if it goes all the way around. And one thing you'll notice about this particular problem is it is more than one time around. Because again, think about this in terms of 2 pi is one time around. 2 pi in terms of 6 would be 12 pi over 6, right? And 13 pi over 6 is more than that. So that means it goes around once. And what's left? So 12 pi over 6 would be one time around. We have 1 left, so it would be 1 pi over 6 left over. So that means this angle would go all the way around once. That's the 12 pi over 6. Plus an additional pi over 6. So is pi over 6 more or less than pi over 2? Pi over 6 is less, so it would be somewhere right about here. Okay, that would be 13 pi over 6. Okay, so I have to name 2 other angles that have that exact same terminal spot. So if I'm looking at the positive way, so the way I went originally, this one went all the way around once and then kept going. What if I didn't go all the way around once? Right? Because I just stopped. So I go here. If you look at this, it would be just this little bit right here. It'd be the same stopping spot. So I started here to here, and we kind of already did that math. It would be pi over 6. So the positive one would be pi over 6, ends at that exact same spot. The negative one would go the negative direction. So I'll do that one, and again, back in pink here. So for this one, I have to start here at this side again. I'm going this way, and I have to stop at this spot. So again, the entire way around is 2 pi. So 2 pi is the whole way around. But this is in terms of sixths, so we can think about it in terms of 12 sixths, right? So if I'm going all the way around, and what's left here, we just said this was pi over 6, right? So the whole way around is 2 pi. So we're taking pi over 6, kind of like we did on the degrees problem, and we're subtracting the whole way around. Or you can do it the other way around and just make it a negative at the end. The only problem is these don't have a common denominator, which makes it kind of challenging to do. So this one's just pi over 6. We can make this the same denominator by multiplying both the top and the bottom by 6, which would make it 12 pi over 6. So I'd have a negative 11 pi over 6. And that would end at the same spot, because the whole way around would be negative 12 pi over 6, and we know it doesn't quite make it the whole way around. It stops here at pi over 6 early. Okay, so that's how I do coterminal angles. If you have questions on this, let me know. You're trying to find another angle that has the exact same stopping spot. The next thing we'll look at is complementary and supplementary. You'll notice I jumped ahead here a little bit and wrote all the notes down. If you want to pause your video and write these things down first in your notes before we keep going, that might be helpful. And then you can follow along as we go. You can also always rewind the video and rewatch it, which is a nice thing about videos. But just a quick review. So complementary add up to 90 degrees, which we probably know from geometry. Supplementary is 180 degrees, which is awesome. The new thing we're talking about is this right here. If we're talking about radians, they add up to pi over 2. Because again, 90 degrees and pi over 2 are the same thing. Just one's in radians and one's in degrees. Same thing here. 180 degrees is the same thing as pi. So if we're talking about radians, supplementary angles would add up to pi. Okay, so when we're looking at supplementary or complementary, just make sure we're looking at radians or degrees. So again, the bottom ones would be radians. The top would be degrees. So on this next example, we have find complementary and supplementary angles for each set. So if I have 24 degrees, if we're trying to add up to complementary, so let's kind of write complementary here. Complementary means the two angles will add up to 90. So if one's 24, that's pretty simple. Looking back at our geometry skills, we would subtract the 24 to get left over 66. So the other complementary angle would be 66 degrees because those two angles would add up to 90. So that's not bad. Supplementary would be 180. So it's basically the same math. I have 180 now. We're subtracting what I know, which is 24. So what would the other angle have to be? You would have to be 156 degrees. I think we should be pretty good on that, based on our geometry skills or things we've done in the past. So complementary, again, adds up to 90. Supplementary adds up to 180. On B and C, you'll notice I put radians questions on here. So we're looking for pi and pi over 2 now instead. So B is kind of a trick question, because if we're looking for complementary for radians, we're looking for them to add up to pi over 2. Right? So I'm saying, what do you add to this to add up to pi over 2? And again, pi over 2 is a half pi, or 0.5 pi. And the reason this question is kind of a trick question is if you look at this right here, it's already more than pi over 2. Okay, it's just like if you had an angle like in degrees. If I gave you a degrees and said 107 degrees, what would be complementary to that? There would be no answer because it's already over 90 degrees. Okay, so this is bigger than pi over 2. So that means there is no complementary. There's none. Because that angle is over 90 degrees on its own. Okay, supplementary we can do on this one. Because if I'm looking at supplementary, it has to add up to 180 degrees or pi. So how I like to think about this problem, just to think about what's going on, is I know it has to be 3 pi over 5 plus something has to equal pi. So some of you can probably do this in your head to figure out the answer, because you have to add up to 180 degrees or pi. Think about it in terms of fifths, because we're doing fifths here, so 3 pi over 5. So if you look at it, what would I have to add? Well, I have to add 2 pi over 5. Because 2 pi over 5 plus 3 pi over 5 equals pi, because it'd be 5 pi over 5. Okay. The other way to do this is if I think about it in terms of fifths, kind of like I did above. So I'm doing 180, which is pi. But in this case, I want to do 5/5 pi, because my initial problem was in terms of fifths. I am subtracting the angle they already have, which in this case would be 3 pi over 5. So what would be left over would be 2 pi over 5. Again, if you add 2 pi over 5 to 3 pi over 5, you would get pi, which is supplementary. Okay, so that's kind of a couple different ways to think about it. I think the second way is probably easier to do the math, but the first way is kind of conceptually what's happening. For the other one, so 2 pi over 7, we'll go back to a different color here. Let's go with green maybe. So I'm looking at complementary. Okay, so complementary would add up to, again, I'm looking for pi over 2. So the two angles add up to pi over 2. So again, I'm going to kind of do it the same way I did here. So I'm trying to get to pi over 2. This problem is in terms of, so I'm doing pi over 2, subtract the angle they gave me, which is 2 pi over 7. And that will give me my answer. Okay. The problem is these don't have the same denominator, so I need to make sure they have the same denominator so I can actually subtract it. So I'm going to multiply the left one by 7 over 7 and the right one by 2 over 2. So I get 7 pi over 14 minus 4 pi over 14. So no, the other angle to make it complementary would be 3 pi over 14. That would be the complementary angle. If we added those two angles up now, they would add up to pi over 2. You can do that if you want to. You could add those two angles up, and you should get pi over 2 to check your work. If I'm doing supplementary, it's the same basic idea, but now it has to add up to a full pi. So it'd be pi, subtract the angle they gave me, so 2 pi over 7. And again, it's going to equal my answer. Okay. So, but again, this one does not have the same denominator, but it's easier because pi has just a denominator of 1. So what I have to do is multiply this one by 7 over 7. This one by 1, which doesn't change it at all. So it'd be 7 pi over 7. Subtract 2 pi over 7, which would make it 5 pi over 7. I think supplementary is a little bit easier because you can look at that pretty conceptually. Look at these two angles right here and here, and you'll look. If you add those two together, you would get 7 pi over 7, which simplifies down to just pi. Okay, so that's what we're looking at, trying to find out what makes them supplementary, what makes them complementary. The angles, the degrees ones are probably the easiest. If you have decimals and things like that, 2 with degrees is still not bad. But complementary and supplementary for radians, just make sure you do it in terms of pi over 2 or pi. And occasionally you have to change the denominators so that they work out and you can actually subtract them. Okay, so your work for today is page 138 and 139. I'll have a picture of that again on the homework assignment here. And it's number 17, 18, kind of jumping around a bit. You have 6 questions, that's it. 20, 21, 22, and 39. Okay, so those are the homework problems. Homework will be due the next day at 10 p.m. So this is due Tuesday at 10 p.m. We'll have another shorter notes tomorrow on how to convert from radians to degrees. Again, let me know if you have questions. We should be good.